Okay. So we're here. So our first exam is this Friday. And I give you, through Canvas announcements, some things about it. I'll maybe hit the highlights again right now. But tomorrow, I'll let you ask questions for as long or as short as you wish. And if you don't ask me stuff, I'll just start chapter 2 stuff. In fact, I might do some chapter 2 stuff even today, but we'll see how it goes, okay? So you turn in all of this stuff, right? I have a 70% requirement, so you must turn in at least 70%. Again, in my opinion, it's not that hard since I've already done, what, half, maybe even more than half of it. So it shouldn't be that hard to do that. Okay, please don't turn it in too early. I'll take it anytime Friday before our assigned ending time, right? So again, the way it works is a little bit after 12, I'll either email the class or I'll send it through Canvas, the exam, so you can print it out. But when you join, I'll also project it. So in case you can't get it on Canvas, I'll show you something like this. So here's an example. This is obviously not our class. So it looks something like this. Okay. It'll say name, row, and seat. Forget that. If we had met on campus, I want to know where you're sitting, but forget all that. Okay. It may not fit on one screen, so there's like 1 through 7-ish. So then you do a screenshot or take a picture on your cell phone. So maybe I'll give you 15 seconds for that. Then I'll scroll down. Yeah, so here's the rest of it. So same thing, take a screenshot or take a picture on your cell phone, give you maybe 15 seconds. And then I put it away. And then you work on it. So ground rules again, you mute yourselves, have yourself muted, but have your camera on. I want to be able to see what you're doing. And again, as I mentioned, I don't want you to have any special background. I want to see your actual background. So some of you guys have, you know, Golden Gate Bridge or outer space or something like that, or it's all green or something like that. I want to see your actual background. I want to be able to see your hands and see your work. Okay, and then Prasanna and I will just look around and see if there's any funny business. So Prasanna, you can help me with that. We're just going to watch. Like it was like if we met on campus, same thing, right? Hey, you know, how come there's that person over there? Or so, you know, on the syllabus, I said you can't use your cell phone. Well, if you take a picture, you know, if you have to take a picture, okay, you can look at your cell phone for that. But if Prasanna or I see you, you know, texting or you're talking on the phone, then that's a red flag, okay? And in Prasanna, you can tell me, hey, you know, something doesn't look right or whatever, and then I'll decide accordingly. Now, I know most of us are at home and stuff happens at home. Yeah, you've got a, I don't know, a little brother, a little sister, or, you know, somebody's at home with you. You know, I get it. That happens sometimes. That doesn't necessarily mean I'm going to give you a 0 automatically, but if I see too much of that, or, you know, if it seems obvious to Prasanna or me that, hey, you're talking, or, you know, there's somebody right next to you, whatever, you shouldn't have your book. Now, you can have your cheat sheet, right? So one standard 8.5 by 11, you can write front and back. But after that, no books, no notes. You can't use people, obviously. You can't use your computer or check online for how to do certain problems. And that's something that Prasanna and I will check for. So let's do it this way. So since you're not supposed to disrupt the class, I guess. So if you do have a question for me, why don't you send it through the chat? Okay, don't unmute yourselves and say anything, because then everybody else will hear it and that disrupts. I know. Think of it like if we were on campus and we had a test, right? If we were on campus and I give you a test, you wouldn't just shout out, hey, what do you do here or whatever, right? Or you might come up and speak to me privately about that. So that would be the equivalent if we had met on campus, right? So if you have a question during the test, just send it through the chat, but don't unmute yourselves because that disturbs everybody else that's working, right? And then that's it. So Prasanna and I will just look around, you know, see if there's any funny business going on. If, you know, you got a friend next to you, or if you're using your book, or you're looking up something on the computer. Now, if you're looking at a piece of paper, you know, I know that you get one cheat sheet. So that would be that. Okay, so that's what's going to happen. So our class ends at 1 o'clock on Friday. So at 1 o'clock, I'll close the class as normal. I'll shut everything off. And then you have 5 minutes. So I'll give you 5 minutes. Get out your cell phone and, you know, click, 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 click for all your pages. and submit it to me. And you know how to do it now because you've had practice. We've had a couple quizzes. All right, so now that you've already submitted a couple quizzes to me, you know the style. And you do the same thing for homework and for exams. So I'll give you until 5 after. So 1:05, you must turn in the test. And then I'll give you until 1:30 to do the same thing for your homework. So click, 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 click for all your homework. But if you want to turn it in earlier in the day, like if you want to turn it in at 9 o'clock or 9:30 and get it over with, then that's perfectly fine to do that for the homework also. Okay? And let's see, what else? You can use a calculator as long as the calculator isn't too good. There are some calculators now that you just push some buttons, it'll do all the calculus for you. And I obviously don't want you to do that. I want you to be able to think. So yeah, roughly 10 questions. So 10 questions, 5 sections. So very logical to have 2 each. So 2 from here, 2 from here, 2 from here, 2 from here, 2 from here. Okay, I'm not promising 10, but it's about 10. Like maybe I might only give you 8 questions, but you know, some questions might have part A, B, C, or whatever. Or maybe some questions are very fast, so then I'll give you 11 or 12 questions. But in the neighborhood of 10, roughly 10 questions. Show all your work. The problems are just like the homework. So they're not multiple choice, true, false, but work them out just like we've been doing in class, okay? So those are the main issues. What else? Calculators, okay. All right, I think that's it. If you have questions, you can put it in the chat, and I'll get to that at the end of class maybe. But I want to go ahead and finish off 1.5 and go back and do some review questions. If I have time, I'll sneak in an introduction to chapter 2. Okay, so here we go. Let's get back to where we were. So some of the problems at the very end, okay, involve some trig and some inverse functions. So how do you do that? So 69, 70, 71, 72, stuff like that. Okay, so let me show you now. Problem 69. Find the cosine of inverse sine of x. Now I know it says prove blah, blah, blah equals radical 1 minus x squared. I'm going to assume we don't know the answer. The square root of 1 minus x squared, pretend that's the back of the book. Okay, so it says prove that cosine inverse sine is radical 1 minus x squared. Okay, I'm not going to make the assumption that the answer is square root of 1 minus x squared. I'm just going to pretend the problem says find cosine of inverse sine of x, and the back of the book gives you that. Okay, so here's how you attack the problem. Okay, first I'm going to call this thing theta, theta for an angle. So let theta be inverse sine of x. So ultimately, I'm trying to find cosine of theta now, right? So let theta be inverse sine of x. So instead of finding cosine of that thing, I'm just finding cosine of theta. Okay, so theta is inverse sine of x. Now rewrite it without the inverse. Get rid of the minus 1. Again, that minus 1 means inverse sine or arc sine. Have you heard of arc sine, A-R-C? Arc sine and inverse sine means the same thing. Okay. Write the same statement without the inverse. That would be sine of theta equals x. Okay. Again, if you want to change an inverse sine to just sine, they are inverse functions. So you just switch around x and y. So you say sine of theta equals x. And maybe an easy argument is to say, if I write it as sine, well, there's only 2 things here. Do you think I'm taking the sine of x or the sine of theta? Well, I'm taking the inverse sine of x. So if I'm taking the inverse sine of x, it wouldn't make sense for it to be the same thing as the sine of x. So I must be taking the sine of something else. But there's only one else. That's theta. So sine of theta is equal to x, which is the same as x over 1. I'm writing x over 1 for a reason. Another way you can think about it, so there's a lot of ways you can think about it. From here, take the sine of both sides, put sin in front, put sin in front. So if I put sin in front of this, it says sine of theta, right? If I put sin in front of this, I would have sine of inverse sine, and whenever you have a function and its inverse, they cancel out. So the right-hand side is also x. So you can see there's a lot of ways you can think of this. Okay, sine of theta is x over 1. Okay, now I do my SOHCAHTOA. Okay, so we call whoops. SOHCAHTOA. Okay, if you forgot it, you can put it on your cheat sheet if you wish. All right, so I draw myself a triangle. I put theta here. You can put theta there, whatever. And here's the right angle. Okay, sine, so, S-O-H. Sine is what side divided by what side? Well, it's opposite over the hypotenuse. So x over 1, so opposite over hypotenuse. So here's my theta, the opposite side is x, and the hypotenuse is 1. So I put x here, 1 here. Then a little bit of Pythagorean Theorem, a squared plus b squared equals c squared. This side is radical 1 minus x squared. Okay, you can do the Pythagorean Theorem for that. Okay, one way you can do that is temporarily call it y. Then you can see I have a right triangle, x squared plus y squared equals 1. Do a little bit of algebra, and you get y equals the square root of 1 minus x squared. All right? Okay, if I call this y, x squared plus y squared equals 1, subtract x squared, take the square root, y equals radical 1 minus x squared. Okay, and then way back up here, I said, ultimately, I want to find cosine of theta. All right, so cosine ca, C-A-H, cosine is adjacent over the hypotenuse. Okay, so this is my theta. The adjacent side is this. So cosine of theta is radical 1 minus x squared over the hypotenuse. So I'm dividing by 1. So radical 1 minus x squared divided by 1. If I divide by 1, I just have radical 1 minus x squared. So that's my answer. Square root of 1 minus x squared. Okay, so the process again, you have cosine of an inverse sine, call it theta, which means I'm now trying to find cosine theta. Okay, so theta is inverse sine. Say the same thing without the inverse. Sine of theta equals x, which I'm going to write as x over 1 to make it into a fraction. Okay. So again, write it without the negative 1. So do I want sine of x? No, I have inverse sine of x, so it wouldn't make sense to have sine of x. I must be taking the sine of something else. The only else is theta. Or you can say I have an inverse function, switch around x and y, so it looks like this. Or you can take the sine of both sides, put sin in front, looks like that. Put sin in front, and here you have sine and inverse sine, that gives me x. So any of those is the same way. Okay. Draw my triangle, I triangulate. Sine was opposite over hypotenuse, so I put this as the opposite side from theta. I put that as a hypotenuse. Do a little bit of Pythagorean Theorem, a squared plus b squared equals c squared. I get this to be radical 1 minus x squared. I find cosine of theta, which is adjacent over hypotenuse. So adjacent over hypotenuse is 1, so radical 1 minus x squared. Okay, 70 is like that also. So let me show you 70. 70 says tangent of inverse sine of x. Tangent of inverse sine of x. So start the same thing, call it theta. So ultimately, I'm trying to find tangent of theta. Okay, this is the same thing. Theta is inverse sine of x. Say the same thing without the negative 1. Sine of theta equals x. So sine of theta equals x, which is x over 1. Draw my triangle. This one's very similar. Mine turns yellow. Okay, sine is opposite over hypotenuse. So the opposite, I put x. The hypotenuse, I put 1. This turns out to be the exact same triangle, folks. So this is also radical 1 minus x squared. Okay, this time I want tangent, TOA. What's TOA? Tangent is opposite over the adjacent, right? So opposite is x. The adjacent is radical 1 minus x squared. So there it is. Tangent of theta equals x divided by the square root of 1 minus x squared. So that's tangent of theta. Okay. And then 72, and that's the last one I was going to do, has a double angle. The problem starts with sine, parentheses, 2 arc cosine of x. And arc cosine means the same thing as inverse cosine. So if you see ARC, arc cosine, or cos with a -1 there, they mean the same thing. This is less writing, but frankly, this is easier to type on your computer, right? Like if you had to type something for me, it's hard to kind of get that -1 up there, but you can just type arc cos, right? If you have to type it on your keyboard. Okay, so this time I'm going to call theta arc cosine of x. Don't include the 2. Don't include the 2. Just theta equals arc cosine of x. Okay, so say the same thing without the arc. Am I taking the cosine of x? No, I'm taking arc cosine of x. So I must be taking the cosine of something else. There's only one else. That's theta. So cosine of theta equals x. Now, ultimately, I want sine of 2 theta. And we have a formula from trig. So we call back in trig, you had a double angle formula for the sine of 2 theta. Here it is, 2 sine theta cosine theta. You had that somewhere before. If you want to put that on your cheat sheet, you may. Maybe it was a long time since you took trig, but you've seen that before. Okay, there was something called double angle formulas, right? There's a formula for sine of 2 theta, cosine of 2 theta, tangent 2 theta, right? So here's the formula you need for sine of 2 theta, 2 sine theta cosine theta. If you forget, put it on your cheat sheet. Okay. All right, so make my triangle and triangulate from there. So cosine of theta is x over 1. So I put theta. Cosine was adjacent over hypotenuse, right? So I put the adjacent here, x. Hypotenuse is 1. The a squared plus b squared equals c squared is exactly the same. So radical 1 minus x squared. Turn on its side. Square root of 1 minus x squared. Okay, so ultimately I want sine of 2 theta. And from trig, sine of 2 theta is 2 sine theta cos theta. Okay, so 2 sine of theta. Sine, so, is opposite over hypotenuse. So opposite radical 1 minus x squared divided by the hypotenuse of 1. So square root of 1 minus x squared. Can't see that. Square root of 1 minus x squared. So that's sine of theta. Cosine theta. Cosine we said was adjacent over hypotenuse. So adjacent is x. Hypotenuse is 1. So x over 1. So 2 sine theta cosine theta. Okay, and the bottom is just 1, so forget about it. So final answer, 2x radical 1 minus x squared. And there we go. Okay, I am actually now done, folks. I'm done with all of this. Okay, I will go back and do some problems now for review. And remember, you can ask some more tomorrow, but I figured out there's some, and some of you already asked me about some of these, so I thought it'd be good to share with the rest of the class. Okay, so I'm done with formal lecture, but now I'm going to go back and do some problems for review. Okay, so let me go all the way back to 1.1, problem 78. Okay, so go back there. So we're in review mode now. Go back and show you 1.178. 1 plus 3x cubed minus x to the 5th. Okay, is it even, odd, or neither? Okay, so remember, to determine even or odd, you replace x with negative x. Everywhere you see an x, put negative x. Okay, so right there, put parentheses negative x. Right there, put parentheses negative x. Okay, so what is negative x cubed? That's negative, so negative 3x cubed. Negative x to the 5th is negative x to the 5th, and then that minus sign makes it positive. Okay, so plus x to the 5th. Okay, if this is the same thing as the original, I would say that it's even. Is this the same as that? No, it isn't. Is this the opposite of this? Still no, not quite. The opposite of the original means you take negative of the whole thing. You have negative 1 minus 3x cubed plus x to the fifth. This is not the same as this, because this one's a 1, this one's a negative 1. Yes, that's the same as that, that's the same as that, but the 1 is not the same as negative 1. So the answer to this one would be neither. That's a neither one. Okay. And let's see, somebody asked for 1.1, no. Or is it? $1.157. A rectangle has a perimeter of 20 meters. Express the area of a rectangle as a function of the length of one of its sides. Okay, so page 22. So here's the picture. So they give me a rectangle and they tell me the perimeter is 20. Okay, so I have a side of x. Okay, so I call it x by y. So what's the formula for perimeter? Well, if this is x, this is y. Here's another x, here's another y. So 2x plus 2y. Solve for y. So subtract 2x. 20 minus 2x equals 2y. Divide both sides by 2. So y equals 10 minus x. So y equals 10 minus x. And now they want an expression for the area. Well, area is length times width. So area of x, A of x, is x times y, which is 10 minus x. So x times 10 minus x, which is 10x minus x squared. Okay. They also ask for the domain of the function. For the domain, well, it's got to be positive. So the smallest it can be is 0.00001 is 0, and then up to 10. Okay. If I plug in 10 right here, 10 minus 10 is 0. That's not allowed. But you can have 9.999999. So the domain is parenthesis 0, 10 parenthesis. That's the domain of the function. You can't plug in 0. Well, you can't have a side of 0. You can't plug in 10, because if you plug in 10, this side would be 0, and that's not okay. But you can plug in anything between 0 and 10. Okay. And let's see. Somebody had asked for 1.541. So let me see if I can get that for you. $1.541 expressed as a single logarithm. Okay, so 1/3 ln x plus 2 cubed plus 1/2 blah 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 blah. If you can't see it, that's okay. I got it on my paper and focuses a little bit better anyway. Okay, so here was the original. 1/3 ln x plus 2 cubed plus 1/2 bracket ln x minus ln x squared plus 3x plus 2 squared. So there's a lot of stuff there. Okay, there's a property of logs that says when I have that 3 there, I can bring it down. Or you can take the 1/3 and bring it up. In either case, the 1/3 and the 3 are going to cancel. Right? If I bring the 3 down, it's 3 times 1/3, but that's 1. So it's just ln x plus 2. You could also say bring the 1/3 up. It would be ln of x plus 2 cubed to the 1/3. Then you would multiply the 3 times 1/3, and that would still be 1. So ln x plus 2. Then for all this junk here, I decided to distribute the half. So half ln x minus 1/2 ln x squared plus 3x plus 2 squared. And then by the same token, that 2 and that 1/2 can combine. I'll just knock them out. Same thing. Either you can bring the 2 down, in which case you have 1/2 times 2, which is 1. Or you can take the 1/2 and bring it up. Then you would have 2 times 1/2, which is still 1. So now it looks like this. ln x plus 2. You have a 1/2 ln x. I'm going to choose to bring the 1/2 up. So ln x plus 2 plus ln x to the half. And then again, that 1/2 and that 2 cancel out. So ln x squared plus 3x plus 2. Now here's what you do. You have ln blah, 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 plus ln blah, 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 minus ln blah, blah, blah. That plus means I'm going to multiply. What do you think the minus means? Divide. So I just write a single log, 1 ln x plus 2 times x to the 1/2. But what is x to the 1/2? Square root of x. And then because I have a minus sign, divided by x squared plus 3x plus 2. Okay, and you can still keep going with this one, believe it or not. Okay, so I'm done with the ln. I'm done with the square root of x. But x squared plus 3x plus 2 factors, right? X and x plus plus means plus plus. And what two numbers have a product of 2 and a sum of 3? 2 and 1. Okay, so I leave the top alone, still got the ln. The bottom becomes x plus 2, x plus 1. And then I can cancel these two out. Okay, so finally, I have ln radical x over x plus 1. And that's my final answer. And you can just leave it like that. That's it. Okay, somebody asked for 1.217, the chirping one, the birds that chirp, 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 something like that. Okay, so let's recall how that went. 1.217. Right? So let's see. If the temperature is 70 degrees Fahrenheit, the birds chirp at 113 chirps per minute. Then if it's 80 degrees, 173 chirps per minute. So the higher the temperature, the more the cricket's going to chirp. Find the equation, slope of that, blah, 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 blah. Okay. So I've got the data right here. 70 degrees, 113 chirps per minute. 80 degrees, 173 chirps per minute. They told us to have temperature as a function of the number of chirps. So I pretend that's like y equals a function of x. T equals f of m, y equals f of x. So as an ordered pair, that would be like x, that would be like y. So number of chirps per minute is the x coordinate, and the temperature is the y coordinate. So I write it as 113, 70, and 173, 80, like x, y. Only it's not really x, y, it's n, t. But we're not familiar with n, t. All of our formulas are with x and y. So I switch over to x and y temporarily and switch back. And now, given 2 points, find the equation of the line. Okay, so first I figure out the slope. So y2 minus y1 divided by x2 minus x1, right? So 80 minus 70 divided by 173 minus 113. That comes out to be 10 over 60, or 1/6. All right, so y minus y1 equals m times x minus x1. The m is 1/6. Okay, you can pick either point. I'll pick this one because the numbers are a little bit smaller. So y minus y1, 70, equals m, 1/6, times x minus 113. And then just some heavy-duty algebra. Distribute. So add 70. So 1/6x minus 113 over 6 plus 70. 70 is like 70 over 1. Multiply that by 6 over 6. 70 times 6 is 420. 420 minus 113 comes out to be 307. So here's the weird equation. Y equals 1/6x plus 307 over 6. Okay. And now change it back because we said x is functioning like n, y is functioning as t. So change x to n, change y to t, and there's the equation. Temperature equals 1/6 n plus 307 over 6. And I know it sounds weird, but if this is true, I'll let you try it on your own. I don't feel like doing it now. But if you were to plug in 113 right here, you're supposed to get 70. You can try it on your own if you wish. And if you were to plug in 173 right there, this should be 80. Okay, the slope is 1/6. It asks what's the significance. For each change of 1 degree, we increase by 6 chirps per minute. Okay, so you increase the temperature by 1 degree, the bird's going to chirp faster by 6 chirps per minute. Okay, so that's that. And then part C, if the crickets are chirping at 150 chirps per minute, estimate the temperature. I'm not going to do it. All you do is plug in 150 right here and figure out the temperature. And so you can do that. Just plug that one in. Okay, so that's that one. Somebody asked for 1.419b. Let me show you that. (1.4), it's on page what? 53. 19b, find a domain, 1 plus x over e to the cosine x. Okay. Okay, no trouble on the top. Only look at the bottom. E to the cosine theta. I would only have trouble if this comes out to be 0. But e to anything is always positive. Little timeout. If you recall the graph of the exponential function, e to anything is always positive. It's never 0. The denominator can never be 0. Therefore, the domain is all real numbers. That's it. Okay, then 1.3, number 41. I think that was another f of g of h one, right? I think I did one of them. I got to do the other. Right. So where are we? Page 44. So f of x, g of x, h of x. Find f, circle g, circle h. So f of g of h of x, right? So here we are. F was the square root of x minus 3. G is x squared. H is x cubed plus 2. Okay, so f circle g circle h means f of g of h of x. Okay, and you say, well, this is too much stuff. I get dizzy. Yeah, but just think of order of operations. Order of operations, you dig deepest one in, right? So I don't touch the f. I don't touch the g. So I'm going to write f paren g paren. That stays the same. The only thing I'm changing now is h of x. What is h of x? X cubed plus 2. So now it looks like this. All right, so now I do g. So forget about the f. F, paren, paren, or bracket, bracket. Okay, and now I apply the function g. What does g do? It squares whatever you give me. So whatever's behind this pen right here, I square it. So it's x cubed plus 2 squared. And now I apply that to the function f. So whatever's behind my pen goes right there. Square root of pen minus 3. So square root of x cubed plus 2 quantity squared minus 3. Okay, so that's how you do that one. Okay, 67A I already did. 63A, somebody asked for quickly, so we may have already done that one also, but I don't mind doing that. 63A from 1.5. Inverse cosine of -1. Inverse cosine of -1. So I call it theta. Write the same thing with cosine. So am I taking the cosine of -1? No, you're taking the inverse cosine of -1. So I must be taking the cosine of something else. There's only one else, theta. So cosine of theta is -1. From trig, I want the x coordinate to be -1. That's way over here. So what is that angle in standard position from here to here? That's 180 degrees or pi radians. So the answer is theta equals pi. Okay. All right, so that's as much as I want to give you there. Looking at the time, I'm maybe going to spend 5 minutes just to give you a quick introduction to something in chapter 2. So you can take notes or not. It's all in the book, and I'm not going to test you on this right here, but just giving you something which will help me for when I start chapter 2 next week. Okay, so on page 78, 2.1. Something called the tangent and velocity problems. Here's a circle. This is called a tangent line. They call it T. Just barely grazes the graph. Okay. Here's a graph, T. It barely grazes the graph at point P. So that's a tangent line. Over here, here's the graph of y equals x squared. Letter T there again, barely grazes the graph T. Okay, that's called a tangent line. Okay, so I'm showing you now top of 79. Show you these pictures. Okay, all these pictures here. So 6 pictures. They have some things the same and some things that are different. So in each case, it looks like they're using the graph of y equals x squared. Okay, y equals x squared, y equals x squared. 6 of them. Okay, they got all these lines here, right? Okay, it looks like the red line is the same. See the red line, red line, red line? They call it T. That's called the tangent line. The blue lines are different. The blue lines are what are called secant lines. S-E-C-A-N-T, just like a trig secant. So what's a secant line? It's a line that touches 2 points of a graph. Okay? So if you have any graph, if you touch 2 points, so you have a graph, right? That's a secant line. Touches 2 points. There's another secant line. Okay? There's another secant line. Okay? So these are all secant lines. Tangent lines would be something like this. Barely graze it. Maybe like that. Tangent line. That's a tangent line. That's a tangent line. Secant line is there and there. So you touch 2 points. Okay, and I'll hasten to add, okay, this secant and tangent have nothing to do with the trigonometric secant and tangent, which is kind of unfortunate. Okay, I mean, you would think they would make up another name, but the word secant, just within mathematics, has 2 different definitions. There's a trig secant, but now we're using the secant as a line that touches 2 points. Likewise for tangent, we have a tangent line. There's a trigonometric tangent also. And there's another English word tangent, I guess, right? Like in ordinary English, you could say, oh, somebody got off on a tangent, right? Or they're speaking off on a tangent. They're going off somewhere. Okay, but so this secant and tangent don't have anything to do with trig. Okay, what are they trying to say here? Look at letter P. The P stays the same in all of them. They're using this concept. Q is the second point. So notice P is the same for all of them. Q moves. Q approaches P from the right. So notice PQ, then Q got closer and still closer. For each of these, there's a secant line. The blue one is a secant. Just drawing PQ, drawing PQ, drawing PQ. Right? Notice as Q gets closer and closer to P, the blue line and the red line get closer together, i.e. the secant line comes closer and closer to the tangent line. Coming from the right side. Q gets closer to P from the right side. Now what's all this? Q approaches P from the left. So again, notice P is fixed. P never moves. Q gets closer to P coming from the left. So QP, there's a secant line. That doesn't look close to the tangent line at all. But move closer. Let Q come closer on the graph. There's another secant line. And then Q comes even closer. And notice as Q gets real close to P, the blue line and the red line get closer together. Same thing over here, right? So when P and Q are farther away, then the red and the blue aren't close. Same thing over here if I'm coming from the left. But over here, coming either from the right side or from the left side, when P and Q are real close, the secant line and the tangent line are really, really close. Okay, that's the only introduction I want to give you. There was no problems to do, but that will help me when I come back to this next week. Okay, so I'm going to stop right there, stop the share. Okay, so let me check the chat real quickly if I can ask. Okay, so 8.5 by 11 sheet. You can have anything you want. You can have formulas. You can have example problems. So if you want, if you want to put down some problems from the homework, you may. Obviously, you won't have room to fit it all. But yeah, you can put rules and laws. That should be fine. And let me see. Why can't I change the chat? Maybe I got to go like this. Okay. So is there a study guide or just use the homework? Just use the homework. The questions are going to be just like the homework. And let's see. Okay. Prasanna sent you a chat. Thank you, Prasanna. Okay. How about we show you our hands? Well, and you don't have to go like this or anything. Just work on the test. But let's say the way I'm up right now, you can't see my hands, right? So I want you to kind of move back enough. A lot of you are already doing this right now. Move back enough so that I can see your hands, so you're not sneaking a book below you or anything like that. Okay. Test corrections, there are no test corrections per se. All right. Questions are just like the homework. I'll either give you the very same questions or just slight variations of it. Okay. Let's see. Can you go over this? Can you go over that? Okay, I'm not sure I have time. I'll see if I can get back to that. Let's see. Okay, I think I'm up to date. Okay, so let me see. What do we have? Maybe 5 minutes. Okay, 1.2, number 6. Somebody asked for. Let me see. number 6. Okay. Let me see if I can get to that quickly. 1 over 1 minus 10x. 1 over 1 minus 10x. Remember, I'm letting you have all of tomorrow, so you can ask questions for the entire period. But if you don't, I'll just keep going with chapter 2. So if you don't want me to do that, then ask lots of questions. Okay, so let me see. Go back to sharing the screen. I hope. Okay, so we got this. Let's find the domain. Okay, so I can't let the bottom be 0. So 1 minus 10x equals 0. Add tangent to both sides. 1 equals 10x. I remember from trig, tangent is sine over cosine. Okay, so I have a fraction equaling 1. When is a fraction equal to 1? Well, when the top and the bottom are equal. Sine x equals cosine x. So from trig, what angles do I know like that? Well, right here and right here, right? So this, you might recall, was radical 2 over 2, radical 2 over 2. Sine and cosine are the same. This was negative radical 2 over 2, negative radical 2 over 2. Okay, in radians, this is pi over 4. this is 5 pi over 4. So if I start at pi over 4, if I add 180 degrees, I'm here, add another 180, I'm here, add another 180, I can just take multiples of 180 or pi radians. Okay, so that would be pi over 4 plus k pi, where k is an integer. And that's what I want to throw out. Okay. These are the values which make the denominator 0. I really want to throw it out. So the domain is all real numbers minus the set consisting of pi over 4 plus k pi, where k is an integer. Like that. Okay. Okay, so that's that. I know I went through it kind of fast, but we already did it, and you can always look back at the video. Show you, I mean, it's not the hands on it. I want to see you enough of your body so it looks like you're not talking to anybody or in any way, shape, or form cheating. And Prasanna and I are going to look for that, see, hey, there's somebody right next to me, right? And you're not sneaking the book next to you. So that's sort of what I mean. Okay. Yeah, please send your homework tomorrow because I don't want to have too much stuff today. So please send it tomorrow. You can send it as early as 7 in the morning or something like that, I suppose. Okay. Sorry. Well, it's 1 o'clock. Sorry, I can't take any more questions, but we can take questions tomorrow. So I'll dedicate the whole time tomorrow. So if you have questions tomorrow, bring it up. But if that stops, I'll just sneak in some of chapter 2 on you, and the test is Friday. All right. Okay. So that'll do it for today, folks. So have a good afternoon.
Thank you.
See you tomorrow. Thank you.
Thank you,
Everyone.
Professor.
Thank you.
Thank you.
Thank you. Bye.
Thank you.